Hey everybody, you know what today is? Today is IAEI News Live Tuesday. Thomas Dimitrovich here, and today's discussion is on the panel board. And it all starts now. All right, put your phones on stun and get ready, because we're going to talk about panel boards, and I'm going to enjoy this session. This is a recorded session. Right now, probably as you're watching this, NFPA 110 and 111 committee meetings are going on. You can tune into. I guess you can't. Yeah, if you asked to be a guest, then you could have been in the 110 meetings with me. But I know you would rather watch IAEI News Live, and hopefully we're both going to learn a lot today. So NFPA 110 and 111 are going on today. I'm a committee member there. Standard for emergency and standby power systems. That's what we're talking about. We're talking about backup power. But today on IAEI News Live, let's hit panel boards. Now, panel boards are all around us. I mean, if you think about it, we talk about overcurrent protective devices, whether it be a fuse or a circuit breaker. You just don't take a circuit breaker and go down to your house and splice a wire and stick it in there, right? You got to put the circuit breaker in something. You have to put your fuse. Your fuse will go into switches. Your fuses can go into switches that then go into panel boards. Okay, breakers go into panel boards. Other types of enclosures. We're gonna and enclosures, right? So we're gonna learn some things today. So one of the things I want to do, I want to cover a little bit about what the 2023 is bringing to the table as well. So I will call up the. I will go out to TerraView, and everybody can do this, right? So you go to www.nfpa.org/70next, all one word, 70 NEXT, and you'll find the public inputs and public comments. Now, I will tell you, to completely understand the changes that were made, you need to look at both the public inputs and the public comments. You can't just go to the comments, because the public inputs made changes. And if the new text of 70 did not change in the public comment phase, when you look at the public comment, the second revision, which they call it the second draft report, when you look at the second draft report, you will not see changes because there were no public comments. Yet, it changed. That's why you got to look at both of them. So we will take a look at the materials, and obviously we're going to pepper in. Get your code book out, and hopefully your code book looks a lot better than mine does. I got a note. Hello, I am the NEC. As you see, I have been abused by the user. Please encourage the owner to treat me with some consideration. That's what it says. And it just popped out of my book. So I was probably in a meeting sitting next to someone who saw my book and said, man, this guy abuses his book. Which, I mean, I travel a lot. So, and I'm sure if you throw this book in your vehicles, you might need to get a couple code books. All right, so the article that we're going to be talking about, well, here's what I do want to do. Some references. Let's talk about some references. I have some links down below. I'll leave the book open. Well, see, here's the nice thing about when your book like sort of comes apart, you can just grab the pages that you need. So anyway. All right, so Article 100, we're going to take a look at Article 100, and there were some changes during the 2023 code cycle. An individual pointed out how we misuse the term. Okay, panel board. Now you would think, how could I possibly misuse the term panel board? Well, we do, and we're going to talk about it today. So you're going to want to go to Article 100. You're going to want to go to Article 408 in your code book. 408 is titled Switchboards, Switchgear, and Panel Boards. UL 67 is the standard for panel boards. So if a manufacturer is going to be making a panel board, they are going to be leveraging UL 67. Now you can't, I mean, you could purchase UL 67, but in my humble opinion, it's probably not worth your money. What you will want to do is go out to UL has a lot of resources online, and remember what they used to call it the white book. In fact, there's a link down below to which I still like, and I know it's old. But so is the standard. I mean, come on. The standard's old too. How old's the standard? Let's take a look at the standard. Let's take a look. Let me do this. I'm just gonna, oh no, I could do this. Yeah, it's still on there. All right. This is what I love about my computer. Let's go to, I have a link for my ULSCCL. I use my little finger to give me my password. And then I'm going to type in 67 for my search. UL 67 panel boards. And it's taking some time. So UL 67 for panel boards is your April 18th, 2022 is the latest edition of the standard. So I'm going to download that one because I can, and I want to make sure that I have the latest version. Because if we talk about it, I want to be able to talk about it with you and reference it. Okay, so UL 67, NEMA PB1, NEMA PB 1.1 and 2.1, each of those documents are for free. All you gotta do is go up to the NEMA website. You can download those for free, and I've got the links down the bottom. Now there's the UL panel board marking guide. That's the days of the white book, which have gone by the by. Now you have, and I'm sure that there will be people posting in the chats for this. This is a recorded session, but Product IQ is a reference for you. And remember, the standard, the standard that a manufacturer would list a product to is not the easiest to understand. So you could confuse yourself even more if you try to dig into the standard. What you need to know is typically available on Product IQ. So you basically create an account out there on Product IQ, and you can type in the words panel board and all that jazz, and maybe we'll get somebody in one day to walk us through that process. But in any case, the resources are for you down below, and hopefully you'll find them of use for you. So let's take a look at Article 100. Now, what Article 100 tells us for the definition, that it has to be a single panel board. So Article 100, I'm going to look at the 2023 definitions because I know you have your 2020 book open. Remember, in 2023, we moved all of the definitions into Article 100. So now remember, anything that I'm getting into is not the opinion of NFPA. It's not the opinion of IAEI. It's not the opinion of the code-making panel members. It's one person. It's my opinion. We all have opinions. We all have a source of knowledge. So just keep that in mind as you listen to this. Question everything you hear and even more of what you see. So that's how we learn, right? That is exactly how we learn. So let's take a look at the definition of panel board. Now, there's a new definition, which we'll talk about. So a panel board, and they did modify the, during the 2023 code cycle, they did make some changes. I'm going to call it up on both the first draft and second draft, because that's what I told you to do, and that is what I'm going to do. So I go to the first draft. Geez, oh man, I didn't even keep track of when I started this. Panelboards. But we're going to get through the whole thing regardless of how long it takes. I think I started around 8 o'clock. Okay, so first change in panelboard. In the definition, you have to remember that when you say the word panel, this is a premise. Here's just from me to you, an easy way to think about this. When you look at that box on the wall that has the door and all that good stuff, take the door. If you take the door off, if you take the dead front off, if you disconnect all of the wires, and then you unbolt the internal guts of that enclosure, what you mount the breakers on, what you put your fusible switches on, that is the panel board. The panel board is not the enclosure included. So what they added in the definition of panel board, when it says, it talks about the assembly in the form of a single panel, including buses and automatic overcurrent devices, and equipped with or without switches for the control of lights, heats, etc. It says designed to be placed in a cabinet and the added enclosure or cutout box. So a panel board is designed to be placed in the enclosure or the cabinet. The panel board itself doesn't include the cabinet. And they added a sentence at the end and then they removed it. So I'm not even going to talk about it. So the key word that they added in the 2023 cycle is they add the word enclosure. Now, is there a difference between cabinet and enclosure? I don't know, but all right. So we know a panel board is what's inside of the box. Now, another term that they added for the 2023 cycle is enclosed panel board. Now, this is new for 2023, and what enclosed panel board or panel board comma enclosed is how you would call it. Panel board comma enclosed. An assembly of buses and connections, overcurrent devices, and control. So we saw that language with or without switches or other equipment installed in a cabinet, cutout box, or enclosure suitable for a panel board application. So it's an assembly of buses and connections. And what the panel board definition said was a single panel or group of panel units designed for assembly. So the panel board enclosed panel board starts with the word assembly. The definition of panel board started with a single panel or group of panel units designed for assembly. So an enclosed panel board is the assembled unit. When I say panel board, I'm sure in your mind, you're seeing a door covering breakers that are enclosed in a box and the breakers are mounted on a bus structure. That's what you're thinking, but that's not a panel board. That's an enclosed panel board. It's the completed assembly of buses and connections, overcurrent devices, and control apparatus. It is not a single panel or group of panel units designed for assembly and must be placed in an enclosure. So there's a difference there. So here's a picture. What you're thinking of, the one is on the right. I guess that's your right. And then there's the other, which is the internal. Now that internal piece can be taken out. In some cases, we'll ship the interiors and the boxes separately. And then you mount the interiors inside the boxes in the field. And that's convenient because you could just get the boxes put in, you can put your pipe in, you can get your wire in, and you don't have the interiors messing up the way. And the painters can come in and do what they voodoo that they do so well. And then you don't have to worry about them painting the bus, and then you bring in and put the interiors in. It can happen. So in any case, there's a difference there. All right, 408.38, it talks about the enclosure. Now remember what 408, the title of 408 is, boy, I'm going to put this book into the Smithsonian. Do you think they'll take it? 408 is panelboard, is switchboard, switchgear, and panelboards. 408.38 talks about, now if you look at where, so let's just talk real quickly about how 408 is laid out. You've got part 1 general, that applies to all of these, switchboard, switchgear, and panelboards. Part 2 is switchboards and switchgear only. Part 3, panelboards. Part 4 is construction specifications. Part 4 starts at 408.50. Part 3 starts at 408.30. So 408.38, we know, is in the panelboards part. So any of the requirements only deal with panelboards. That's another important thing to remember. You've got to understand where you're at in the code. If you're looking at 408.38 and thinking you're going to apply it to a switchboard or switchgear, that would be wrong because you're only in part 3, panelboards. All right. And then there's a part, I said part 4. I don't know if I did or not. Construction specifications. And that starts at 408.50. All right. So we're going to talk about part 3. We'll talk about part 1, part 3, and part 4. So this is in part 3. Enclosures requires the panel board to be installed in a cabinet, cutout box, or identified enclosure. So that's pretty clear. And 408.38. I don't know if they. Let's take a look at what they did in the 2023 because they could. I'm trying to think, sometimes we have a new term, enclosed panel board, but then you have to make sure you use enclosed panel board in the code, because if you don't, then bada bing, bada boom, bada bang, it's gone. But I believe we did make changes in 408. I hope we did, because the definition change for enclosed panel boards was in panel 1. Panel 9 covers panel boards. So let's take a look at 408.38 in the 2023 cycle. Does not look like any changes occurred in 408.38. So, but I'm gonna compare first draft and second draft, because that's what you got to do. 408.38, and this is what we'll do in this hour. Oh, 408.38 did change. Oh yeah, I remember this change. So 408.38 says the panel boards have to be mounted in cutout boxes or identified enclosures and shall be dead front. So we know we have to have a dead front, all that jazz. That's the dead front's that piece that, so when you open that outer door, you have a dead front that's going to keep you from touching anything energized. They added, when the available fault current is greater than 10,000 amps, the panel board and enclosure combination have to be evaluated for the application. So if you, and I would say that that's probably some vague language. Because if the available fault current is less than 10,000, you still have to evaluate it for the application. Just not in regard to available fault current. You still have to make sure the enclosure is listed for the environment. That does not cover there. The panel board enclosure combination shall be evaluated for the application. That's a pretty broad statement. So if the fault current is less than 10,000, then I don't have to evaluate the panel board and enclosure combination for the application. What does that mean? That's pretty generic. Does that mean I don't have to consider the environmental conditions? Does that mean I don't have to think about HAZLOC? I don't know. In any case, HAZLOC's back there. But anyhow, I would say that should not. I believe all they're talking about is evaluated for short circuit current rating for the application, because all panel boards are going to be apparently greater than 10,000 amps short circuit current rating. I think we need some love. I think that new change needs a little bit of love next cycle. I don't know. You tell me. Use the chat. That's what the chat's for. Let me tell you. This session is only great because of you. You need to chat it up, comment on it. Tell me what your thoughts are. Do you like that language? Where the available fault current is greater than 10,000 amps, the panel board and enclosure combination shall be evaluated for the application. So if it's less than 10,000 amps, you don't have to evaluate the panel board and enclosure combination for the application. What does that mean to you? Do you like that language? Do you hate that language? Do you just want to hug that language and give it big kisses? I don't think so. But anyway, I would hope not. All right, 408.38. Now let's talk about it. So panel boards can have molded case circuit breakers and or fuses. You're not going to see an insulated case circuit breaker or a power circuit breaker inside of a panel board. It would be kind of hard to fit those big breakers inside this panel board, but panel boards do go up to up to 1,200 amps. Think about that. They go up to 1,200 amps. That's pretty high. And I know there's a term, load center, that a lot of us use. In fact, here's what I'm going to do. I'm going to go out to NFPA link. I think it's called NFPA link. Sign into NFPA link. If I go out to NFPA link and I'm going to search the code for load center. I'm going to search the National Electrical Code for the 2020 version, load center. Let's see if it's out there. 0 results. I'm going to search. Can I select all? Oh man, reset. There's no way to search all. I thought there was. Anyway, here's if you're out there from NFPA, if my buddies are out there listening, it would be great to be able to search all NFPA publications for a word. I can't do that. Doesn't look like I can do that. Tell me if I can, or if I'm doing this wrong. I can do all of NFPA 70, and I can do select publications, but I can't search everybody. So, but suffice it to say, in the National Electrical Code, the term load center is not used anywhere. A load center, a residential load center, is a panel board. Load center, that term, is a marketing term. It's a differentiator that manufacturers have come up with to differentiate something that you would put into a residential home as opposed to something you would put into a commercial building. Can you put a load center in a commercial building? I don't see why not. long as it's listed for the environment. Unless it's less than 10,000 amps, then you don't have to evaluate it for anything. Anyway, 809, love you. So panel boards and load centers are one and the same. And you can go up to 1200 amps in a panel board. Those are big ones. Up to main lug only, 1200 amps, main circuit breaker, 1200 amps, all that good stuff. This is an example of a 240 volt maximum panel board. 3-phase 4-wire, 3-phase 3-wire, single-phase 3-wire, 600 amps, 400 amps, 100 amps, bolt-on breakers, tin-plated, aluminum bus, or silver-plated copper. So many manufacturers will have different arrangements. Now, well, we'll get to it. All right. I said we'll get to it, and look, it was the next slide. I wanted to talk about short circuit current rating. So this 408.38 talks about being evaluated for the application less than 10,000 amps. So you can get the short circuit current rating of a panel board. Remember, what is a short circuit current rating? The short circuit current rating is the ability of the equipment to hold it together while fault current passes through it. It has nothing to do with stopping the flow of current. It is the ability of the bus structure, the mounting of the bus structure, the mounting of the components on that bus structure, being able to withstand, hold it together under the magnetic forces of pressure of the current passing through it. That's a short circuit current rating. So you can get up to 200,000 amps. Now, the way they determine a panel board is not marked by the manufacturer. Oh, this is a good one. A panel board is not marked by the manufacturer with a short circuit current reading. Now, oh boy, I'm watching. I can see you cringing right now. I can just hear the gnashing of teeth and people saying, what did he just say? Because I make panel boards, and I've had this discussion, and I mark the short circuit current rating on my equipment. He is baloney. Let me tell you why I say that. Because it's true. We do not mark our panel boards with a short circuit current rating. I'll tell you what we do mark it, and I have one right here. So let me do this. And see, it's right there. Can't you see it? I need to zoom in. End show. How do I zoom in? How do I zoom in? Tips and show. Here's what I'm going to do. Here's how you zoom in. Watch. And then we're going to maximize this. Because this is a label out of a panel board. And I am going to show you what I mean. Breaker handles, when the main breaker panels are insulated. Oh, look here. Main breaker. So series connected, short circuit current rating. This is the series rating table. Remember, this is now look at this. These are the series ratings capabilities. Now, what this will tell, look at what it says is series connected short circuit current rating. Feeder breaker, this has your main or feeder. And look, there's fuses. And then these are all of your branch integrated. Now, remember, I can put different circuit breakers inside of this panel. And depending upon the breaker that I put installed inside of this inside of this panel will determine the short circuit current rating of the equipment. Additional or replacement breakers shall be of the same manufacturer and the type, shall have an interrupting rating equal to or greater than the interrupting rating of any circuit breaker installed. The lowest interrupting rating of the circuit breaker, of any circuit breaker that's in this panel board, the lowest rating is the short circuit current rating of that equipment. That makes sense. So I'm just looking to see if there's another good example. I know I had some good labels in here of panel boards. Take a look at, oops. Nope, you don't want that one. Let's take a look at this one. Yeah, so this is a switchboard, but I'll show you what I'm saying. So this is a label, and it basically says the short circuit current rating of this switchboard section is equal to the lowest rating of 1, any section electrically connected in series, or 2, any installed panel board having a marked short circuit current rating, or 3, any device installed except as noted. So they give you a recipe for how to determine the short circuit current rating. They're not telling you what the actual short circuit current rating is, because it depends on what you install. Here we go. Here's another one. Here's a label here. The short circuit current rating of this panel board is equal to the lowest current interrupting rating of any device installed, except as noted in the series rating information manual attached. And that other label that I was showing you, that was a series rating table, told you what had to be upstream and what had to be downstream. So I can't mark in the factory a short circuit current rating outside of maybe a fusible panel, right? A fusible panel with a fuse as a main, I can mark that because I have rejection features, etc., that will keep it at 100,000 amps or 200,000 amps. But when it comes to circuit breakers, my interrupting ratings change, and they'll fit in the same slot, right? So you take out a 22K circuit breaker, you go down to the supply house, and you say, I need a 20 amp circuit breaker. It's 22K, but do you think that they're going to look at the side of the breaker and go, oh, this is a 22K? Now, hopefully what they do is they look at the catalog number. If you bring the breaker with you, if you just go down and say, hey, I need a 20 amp breaker, then they're going to go, well, what panel's it in? Well, I need a whatever catalog number for whatever manufacturer that you're dealing with. Say it's, I don't know, it's you tell him the load center it's going into. He goes out and gets you a 20 amp breaker. You think he's going to come back with a 22 or a 65K? He's going to come back with a 10K. And the moment you put it in that panel board, you've lowered the short circuit current rating of the panel board, because the short circuit current rating of the panel board is equal to the lowest current interrupting rating of any single device that's installed. And if it's a series rated system, you need to make sure that you get the exact catalog number that's a part of that series rated system. That's where the upstream and the downstream work together. And we're going to talk a little bit about that as well. So panel board's short circuit current rating is an important data point that you need to be thinking about. Now let's get back to the PowerPoint. Where was I? All right, and now, so retrofit panelboard interiors. So if you have an existing enclosure out there, there are manufacturers that make enclosures, interiors that will go inside of an enclosure. You've got to come up with the dimensions of the box, and they'll tell you what size, like how many breakers you could put in there, and those calculations are based upon bending spaces, etc., which are a part of the code remember, we had in part 5.4 construction, they'll talk about panels, bus bars, protection of circuits, component parts, maximum number of overcurrent devices, wire bending space within an enclosure containing a panel board. There's A, B, C. There's a top and bottom wiring space. There's a side wiring space. There's a back wiring space. So you got to think about all that. The manufacturers of these devices will tell you the size of the enclosure, or you tell them the size of the enclosure, the depth, and all that good stuff, and they'll tell you what interiors will fit in there, taking care of that wire bending space that's in part 4 of Article 408. 408.9, there's a new, what am I doing? There's a new requirement in 408.9 for the 2023 code cycle that talks about replacement panel boards. They're permitted to be installed for an existing installation, which would be in enclosures. And where would you do this? You would do this in, say you have a school and you have a bunch of panel boards that you want to update. You could take the interiors out, not bother the infrastructure. You don't need to worry about plaster and all that good stuff. You're using the existing enclosure. All the wires are intact. You're going to take the interior out, the panel board, put a new panel board inside that enclosure, and 408.9 is going to govern what you can and can't do. So panel boards listed for the specific enclosure. So if I have a single manufacturer that's listed for that enclosure, then if you take a panel board, put it into that enclosure, then you'll retain the short circuit current rating of that equipment. But remember, it's going to be dependent upon the breakers that you put in it. Remember, the manufacturer gives you a recipe on how to determine the short circuit current rating based upon the overcurrent devices that you place in it or what's upstream. Panel boards not listed for the specific enclosure, if the available fault current is greater than 10,000 amps, the completed work shall be field labeled. So what you'll have to do, if the available fault current is greater than 10,000 amps, and you're going to use a retrofit interior, then you're going to need to get like an AHJ out there, or a field evaluation body, an FEB, which is defined in the NEC. The FEB and the NEC from the NFPA will get it done ASAP PDQ. So the completed work shall be, if the fault current is 10,000 amps or less, then the replacement panel board shall be identified for the application. Any previously applied listing marks in the cabinet that pertain to the panel board have to be removed. You want to maintain the marks, the labels for the enclosure, and understand the difference. Don't just start removing labels. Just remove the label associated with the panel board. All right. All right. So that's sort of what the new 408.9 is. We already talked about the short circuit current rating. Now, what the 2020 code did was added the field marking for available fault current other than dwelling units. So it says, other than 1 and 2 family dwelling units, the available fault current and the date the calculation was performed shall be field marked on the enclosure at the point of supply. So you've got to mark the enclosure with the available fault current. Why? Because we have to compare the short circuit current ratings, etc. And then, you know, obviously you're going to have to keep those updated. But at least that tells you what ballpark, what breakers to buy. I could argue that that would change over the years, and you should maintain your short circuit, your labels. And that's a good 70B discussion. So that's 408.6. All right. Let's think about what other ones here. Let's talk about services. So services. Article 230. A lot of changes have happened over the last few cycles around services. Why is that? And I would argue that a service, the reason, so a service is a pretty hazardous, I don't want to say hazardous location. I mean, that's a defined term. A service is pretty dangerous. And why is that? When I take the dead front and expose, even if I turn the main off, even if there's a main inside of the panel board, I turn the main off and I remove everything, I do have energized parts in that panel board. And if I, even with the main off, and that's those main lugs, the only way for me to turn those off is to call the utility. I have a similar hazardous, similar dangerous location on the secondary of every transformer inside of a facility. I have energized mains, lugs, if I have a main overcurrent protected device. And the only way to kill that power is to turn power off upstream, which may be the line side of the transformer, which may or may not be able to do that, depending upon the application. I could argue that you have justified energized work in this panel board because you have these exposed lugs, because multiple panel boards are fed from a single transformer, which is permitted by the code. And maybe the other panel boards are serving emergency loads, or other loads that maybe they're not emergency loads, maybe they are loads that you can't turn off without creating an additional hazard. You know, go back to NFPA 70E. So what we did in 230 and what you're going to see in the 2023 code cycle is we reduced the likelihood of an event from happening. Remember, risk is comprised of two things: likelihood and severity. Remember that. Because you can look at everything you do through the eyes of risk, likelihood, and severity. What is the likelihood that I'm accidentally going to touch something in this panel board? It may be dependent upon the work that you're doing, where you're located, the work that you're doing, how you're doing that work, all that jazz. So what 230 did was it recognized that, look, if you have and it actually started in 408, where we added the word panel boards when it comes to barriers. This change is about shock, but it does reduce the likelihood of coming in contact with energized parts, even though the main is turned off, because those main lugs are still energized. So I reduced the likelihood of shock. I also reduced the likelihood of an arc flash event. Why is that? Because if I reduce the likelihood of you accidentally coming in contact with energized parts with either you or a wrench or a screwdriver or a conductor, whatever it is, I reduce the likelihood of that from occurring, then I've reduced the likelihood of shock, and I've reduced the likelihood of an arc flash event caused by your actions. So barriers provide a means to protect the electrical worker from contact. Now, 230.62C has a new section, barriers. Let's take a look at 230.62 in the 2023 code. This is the nice thing about having Terra on your computer. 230.62. I don't even know what time it is. I don't even know when I started, but we're going to get to the end of this. And we're going to do it at our own pace, because that's how we roll. 230.62, service equipment, enclosed or guarded. I'm going to call it up in both the first draft and second draft. 230.62. All right. Service equipment, enclosed or guarded. First draft just added a simple sentence on in C. with the service disconnect in the open position, and nothing changed in the second draft. So all of this stuff is really good. What this speaks to is a line side barrier. This is an example of a line side barrier. I call them booties. Put that around the line side, and that reduces the likelihood of coming in contact with something that's energized on when you turn that overcurrent protected device in the off position. That's wrapped pretty tight. It'll prevent incidental contact. If I can reduce the likelihood of you coming in contact with that, whether this panel is at the service or if it's on the secondary of a transformer, because we made some changes in Article 215 for feeders. I believe it was 215. Yes, 215.15. Check that out on the 2023 code cycle. If you have a panel board on the secondary of a transformer, if you have a panel board at the service equipment, you're going to have to put these barriers on it. And why is that? The incident energy at the service, the incident energy at the on the secondary of every transformer, the incident energy is high. Why is that? Because the clearing time is based upon the primary overcurrent protective device, which is intentionally inflated in size to handle inrush currents. So I inflate the size of the primary overcurrent device, which will put that device outside of providing arc reduction. It'll put the arcing currents in the long time clearing time, and your incident energy at that first panel board is true to roof. True to roof. It's a West Virginia term. All right. Now, another area, 24086 series ratings. Remember, we talked about the short circuit current rating. Now, the short circuit current rating, what did we say in that label? It's dependent upon the lowest interrupting ratings, or if you have a series rated pair. So what is series? This is a fully rated system. So I have a fault current of, say, 31,000 amps. I've got a 65K breaker upstream, a 65K interrupting current breaker downstream. That's a fully rated system. This is a series rated system. I have 31,000 amps of available fault current. I have a 65K breaker upstream. I've only got a 10K breaker downstream. If I would enforce the code, I would say that 10K breaker cannot interrupt 31,000 amps. So I have to remove it and I have to put something greater than 31,000 amps there. Maybe a 42K would be a fully rated system where all of the overcurrent devices can clear the fault current. But in this case, the 65 and the 10K, if I use a series rated pairs, which would be section 24086. 24086 is another one for you to remember, and go check it out because a lot of people miss the details in 24086. These pairs of breakers have to be able to handle the available fault current at that bus. Now, you'll notice I have breakers downstream and I have a square box upstream. Why do I do that? Because the upstream overcurrent device can be a circuit breaker or a fuse. The downstream device will always be a circuit breaker. I can never have a fuse downstream, protected by a circuit breaker or protected by another fuse. I can only use a circuit breaker downstream because the circuit breaker will have a lower interrupting rating. If I have a 10K interrupting rating fuse downstream, I cannot put anything upstream to increase the short circuit current rating of that equipment and protect. And two fuses ain't gonna happen. Okay, so 24086A tells you how to deal with with existing systems. 240.86C deals with the motor contribution. I would say this one is missed by many engineers out in the field. They forget about 240.86 Charlie. Motor full load amps, I'll talk about why. And then you have to have it properly field mark. And you don't get selective coordination with a series rated system. So if you see a series rated system and it's an Article 700 system, red flags go off. Now, motor contribution. This is what's missed very often. and I'll show you why. A series rated system. When I have an upstream device and a downstream device, those devices are tested in pairs. Both devices see the same current, and they will both open to clear the fault together. But if I have motors and motor contribution, the downstream overcurrent device, because of the way the currents flow, the downstream overcurrent device is going to have more fault current passing through it than the upstream overcurrent device. These devices have never been tested that way, ever. They are always tested with the same amount of fault current passing through both of them. So what the code does is it limits the amount of fault current that you can contribute from downstream motors, not upstream. Because if it was upstream of that main overcurrent device, then all of that current would be flowing through both devices. Only when the motor contribution is in between the two devices, like what you see here. I can't exceed 1% of the interrupting ratings of the lower rated circuit breaker. So I add up all the full load amps, and I can't exceed 1% of the lower device interrupting rating. So 408, we already talked about what this is separated into. You've got 408.8 reconditioned equipment. That's in the 2020 code. What we did in the 2023 was we moved that to 408.2. And panel boards are not permitted to be reconditioned. Rating requirements are in part 3. You got ratings, you got your overcurrent protection, you got damp and wet locations, and you have the enclosure. Panel board ratings not less than the minimum feeder capacity. And you calculate your load, and the panel board has to be able to supply the load. Obviously, it could be much greater, but it can't be less than the load. And they point you back to 220. 408.36 says that you have to be protected by an overcurrent device and rated not greater than that of the panel board. So if you have a 400 amp panel, you need a 400 amp device. You can't be greater than that. You can put a 200 amp overcurrent device feeding a 400 amp panel, but you can't put a 600 amp overcurrent device or an 800 amp overcurrent device feeding a 400 amp panel board. The overcurrent device must be located within or at any point on the supply side of the panel board. There's 2 exceptions, and these are important because a lot of people miss these 2 exceptions in 408.30. So 408.30, that moved. It must have. 408.36. 408.36, not 30. Oh, it's a 408.30 plus. All right, so panel boards must have a rating not less than, so that's it's referring back to 408.30, and there's additional things that you need to do. In 408.36, supplied through a transformer. So this is one that's always very commonly, you have a panel board on the secondary on a transformer, and they'll say it's a main lug only panel board. And you go, main lug only. Well, how are you protecting that panel board? Where a panel board is supplied through a transformer, the overcurrent protection required by 408.36 shall be located on the secondary side of the transformer. Now, there is an exception, and the exception is when you are on 240.21 Charlie 1. I'll grab the first half of my book, and I'll tell you what 240.21 Charlie 1 tells us. 240.21 Charlie 1, transformer secondary conductors, protection by primary overcurrent devices. When can that happen? When you have a single phase or a multi-phase, other than delta-delta, transformer secondary conductors are not considered to be protected by the primary overcurrent protected device. So if your secondary is Y grounded, you are not in 240.21 Charlie 1. 240.21 Charlie 1 are for the secondary side of a single phase transformer having a 2-wire single voltage secondary, or a 3-phase delta-delta connected transformer having a 3-wire secondary If you don't have that, if you have a Y-grounded system, you are not able to protect this panel board from the primary overcurrent protective device of the transformer. So it's very rare that I have ever seen anything that doesn't violate the NEC that didn't have a main the best design, in my opinion, come off the secondary of a transformer, land on a switch, and then go to a main lug only panel board. Why do I love that one? Because the incident energy in that panel board is going to be based upon the overcurrent device on the secondary of the transformer, which is in that switch. And that will reduce the severity. As long as the available fault current and the arcing current is in the right region of that fuse, obviously, but your likelihood of that happening is much greater than if you're relying on the primary overcurrent protective device of the transformer. Just saying. All right, so supplied through a transformer, something that is often missed. Oh, reverse circuit for reverse feed, backfed devices. This is 408.36D. It says plug-in type overcurrent protective devices or plug-in type main lug assemblies that are backfed and used to terminate field installed ungrounded supply conductors shall be secured in place by an additional fastener that requires other than a pull to release the device from the mounting means on the panel board. So these are plug-in type, not the bolt-in type. Also keep in mind that if I have a circuit breaker that's marked line and load, I cannot backfeed that circuit breaker. Not all circuit breakers can be backfed, or switches. Anything that's marked line and load. If it's marked line and load, that is one side is line, the other is load. Don't forget it. All right, 408.43. This saw a little bit of a change. You can't put the panel board in the face up position. 2023 is going to tell you you can't put it in the face down position either. That's 408.43. And there's no exceptions. Maximum number of overcurrent devices, 408.54. Don't exceed the number of devices in the panel board designed to handle. No MacGyvers, please. They are not, you just don't want to do it. Panel board has to be marked durably. That doesn't mean that you just have to put a little extra oomph. It has to withstand the environment. You have to have the voltage, the current, the number of AC phases, and the manufacturer's name or trademark. Take a look at the link down below to the UL marking guide, because it'll tell you all of the different marks that you may see on a panel board and why they're there. That's a good resource. I love that resource. Service entrance and other largest equipment. You have the 6 disconnect rule. You're never going to see a panel board, service entrance panel board, without a main. It's service entrance rated. You're not going to see it without a main overcurrent device because of the changes in 230.71. Keep that in mind. Line side barrier. So they expanded it to much more than just panel board, switchboards, and switchgear. These are just the different things that you're going to see. In surge, some panel boards, the challenge with surge is how do you add it if you don't have any additional spots. So some manufacturers, I think pretty much every manufacturer of breakers, will have integrated surge where you can take, say, a 30 amp or a 60 amp circuit breaker out, put a 60 amp breaker back in again, and it has surge that protects the entire panel and connected loads. Article 110, requirements for electrical installations. This is the identification. I love the duct tape rules, right? 110.22, the disconnecting means shall be marked to indicate its purpose unless located and arranged so the purpose is evident. Engineered series ratings. We already talked about series ratings. That's in 110.22. You'll see labels like this. And what I'm telling you, if you're working on a panel board and you're replacing overcurrent devices and you see these signs, series combination system, and what the rating of the amps is, make sure that you get the exact catalog numbers. And if you can't find the exact catalog numbers, you're going to have to go back to the tables, these books that we'll publish, and find out which ones work. Because you may have to re-series rate that system if you can't get that specific breaker or fuse. All right. That was my discussion on the panel board. Hopefully you hung in there, and I believe it's just about an hour. Keep in mind, there are different things, if you think about the different phases of construction. You'll have a design phase, you'll have the installation phase, and then you'll have the ongoing maintenance, and you'll have an end of life. The National Electrical Code is a great reference for both the design and installation, because the NEC is going to tell us the ratings that we need and all that jazz. When I start getting into after it's installed, I have to think about the maintenance of my panel boards on all my electrical equipment. But panel boards, since this is our discussion, the maintenance of that panel board, you're going to be dealing with any holes that are in the panel board. If you remove a conduit because you've taken a circuit out, make sure you plug all of those holes. Make sure that the integrity of the structure, if it's rusting, if it's in an environment that, let's say, either a caustic environment or outside, make sure that the integrity of the box is still there. In some cases, you may be able to say, look, we're going to take this out of service, replace the enclosure, and use the interior. The interior is in great shape. You can take the interior out, put another enclosure in place, talk to the manufacturer, get the right enclosure for the panel board, and bring the enclosure back up to speed. In some cases, you may have to replace everything, depending upon the environment. Go take a look at NFPA 70B, and 70B just became a standard, or it's going to become a standard here shortly. There's maintenance. I'm going to take a look at if you think about how 70B is laid out, you've got the first so many chapters, say up to chapter 9 are your general, I would say, requirements. When you get to chapter 10, you're starting to get into like your hazardous locations and things like that. But panel boards is covered under chapter number 13, panel boards and switchboards. And they'll tell you what the visual inspections for panel boards and switchboards. Inspect the external physical condition. Remember, I just told you that. Inspect the anchoring and grounding. So if you see maybe the enclosure's doing great, but what you mounted it to isn't. The integrity of the structure that you're mounted to makes a difference. Verify the breakers and fuses and overload elements are the right sizes and types based upon the studies, which could be a short circuit study, coordination study, all that jazz. For connected communicating addressable devices, verify the device addresses are set in accordance with the documentation. Why? What does that have to do with the panel board? Well, if you don't have those devices, you're not protecting the conductor. If you're not protecting the conductor, you can have overheating, and then boom, unintended rapid disassembly in the field. Verify instrument transformer ratios. Inspect the insulators for contaminations. Verify any filters. So you might have filters installed where you want airflow going through, but you need to filter out depending upon the environment. Verify barriers are in place. Visually inspect the environmental controls and all that jazz. And then they have cleaning, bus insulation, cable insulation, terminals and terminations, electrical equipment surfaces, enclosures, and insulating materials shall be kept in a clean and contaminant-free state. Don't violate that by bringing chemicals to the job. If you're going to wipe anything down with anything other than dry components, if you're going to add anything, Consult the manufacturer. Terminating devices, mechanical parts, lubrication in accordance with manufacturer's instructions. Mechanical servicing, ensure maintenance devices and tools are available. Inspect the anchoring or grounding. Mechanically operate the circuit breakers or switches. And why is that important? Because remember, the short circuit current rating is dependent upon the breakers and overcurrent devices doing their job. If you don't maintain the overcurrent devices that are in there that are needed to establish your short circuit current rating, then you're not going to have a short circuit current rating that you expected to have. So verify mechanical indicating devices are functional. Verify fuse holders, provide mechanical support. Anything inside, so it's the outside enclosure that, from a mechanical structure perspective, and the inside components. Electrical testing. Check the electrical hardware connections, and that's torque and whatnot, and they reference you to Chapter 7. Measure insulating resistance of the main bus. Measure the insulation resistance of control wiring. Test protective devices and systems. For surge devices, surge arresters, and arc fault energy, see the manufacturer's instructions, but obviously you're going to test all the individual components, whether it be breakers, relays, all that good stuff, based upon their individual chapters. You have to do your operational tests, like if it's if your panel board is a part of a transfer switch, manual transfer switch, you're going to manually transfer. Make sure all of that is functional. Test control power transformers, instrument transformers. Where environmental controls, remember this applies to switchboards and panel boards, so some of these tests may be only applicable to switchboards. We probably should break out panel boards in the future. And that's it. So there's not much you need to do for panel boards, and then there's so much you need to do for panel boards. All right, do you have your IAEI membership? You need to get it if you don't. I'm telling you, there's a lot of resources. The IAEI is bringing a lot of value to the industry. We need your support. We would love to have your support. We would love to have you as a member of IAEI. Make it happen. Links are down below. Also, check out the online information from IAEI. There's a lot of information out there that you may find available, informative and useful to helping you achieve your goals in your careers and around electrical safety. And that's our program today. Panel boards in a nutshell. Hopefully you got something out of our hour today together. And if anything, you've got some good resources down below. I really appreciate you spending time with me, and I enjoy these sessions, and I hope you do as well. Remember to please stay safe, stay healthy, and I'll see you next week. Signing off. IAEI News Live. Thanks.